Question 2 on the high-speed train situational problem, practice situational problem, is a question involving using scale on a map. And this is, I would say, the one in this practice situational problem that I had the most questions about, the greatest number of questions. So there's a number of steps you want to keep track of. Whenever you're trying to figure out a distance using a real map where it gives you a visual scale, like this, a few terms I just want to make clear to you. There's three kinds of scale that you'll often see. One is a visual scale, like the one you see there, where you have a line, or sometimes it'll look kind of like a sideways ladder with a number there indicating what that line means. Here, like you'll see this on Google Maps a lot, it's telling you that 20 kilometers in real life is represented by this stretch of line on the map. The other kinds that you'll see is you'll sometimes see a scale that says something like this. This is telling you that a centimeter on the map means 3 kilometers in real life. And the third kind that you'll see, what we call a ratio scale, looks something like this. This tells you that one of anything on the map is 1,000 of that same distance in real life. Like for example, if you measure and you see that, oh, this is 3 centimeters, you would just multiply that by 1,000 to find out what that 3 centimeters on the map means in real life. Now in this map, the scale is not 1 to 1,000, so that wouldn't be accurate. But I think you get the idea. Okay, so in this specific example, your first step would be to figure out, when I see this 20 kilometers here, how long is that actually physically, how long is that physically using a ruler? So you'd get out your actual ruler on the piece of paper and you would measure how long that is. Now, in the version that people had, it was a little bit cut off because the hole puncher put a hole here so you couldn't measure it very accurately. But if you had the same version that I have here, when you'd measure this, you'd get 20 millimeters. Say, sir, isn't that the same thing as 2 centimeters? It is the same. But in a situation like this, it's a lot easier to use millimeters because let's say you had not 20 millimeters, but 19 millimeters. Right? 20 millimeters is easier to deal with. There's no decimals. 1.9 centimeters isn't really a problem. As long as you keep track of your decimals, you should learn and be able to do that. But you're just a little bit safer, taking away a little opportunity for error away from yourself here. So when I measure this and I get 20 millimeters, I say to myself, 20 millimeters on this map is the same thing as 20 kilometers in real life. And what I'm doing here is I'm setting up, this is not quite a ratio yet because a proper ratio doesn't have any units in it, but it's building me towards a good ratio. I've got 20 millimeters, that's what I measured with my ruler. Means 20 kilometers. I'm getting that number from here in real life. And this I can turn into a ratio scale. Before I do that, however, a step that a lot of people forget to do is get them the same units. I have a lot of people taking a ratio like this and telling me, oh, that ratio is 1 to 1, because they just see the 20s and they forget that we're dealing with different letters here. No good. Get these guys in the same units first. So you say, all right, let me decide. I can either get everybody in millimeters or everybody in kilometers or everybody in some third unit. Here would probably be easiest, again, if you're not a big fan of decimals and you prefer dealing with a bunch of zeros than dealing with a bunch of decimals, is get everybody in millimeters. The 20 millimeters is already in millimeters, and the 20 kilometers, if you count, you do your, King Henry died unusually drinking chocolate milk or whatever it is, you end up finding that to go from kilometers to millimeters, I've got to add 3 zeros. So your 20 kilometers becomes 20 million millimeters. That's your next step. Your first step, you just measured and you said it was equal to what the number says. Now you're doing a little unit conversion here to get 20 millimeters is equal to 20 million millimeters. Now, equal isn't quite the right word, but 20 millimeters represents 20 million millimeters. Once you have the same units, that's great because now you can just forget about them. You can cross them out and you have a pure ratio, 20 to 20 million. However, since when you're giving me a ratio, I expect them to be reduced as much as possible. Your 20 to 20 million needs to be reduced just like you'd reduce a fraction. Say, is there anything that I can divide both sides of this by to get to reduce it, to simplify it? And actually, in this case, it's nice and easy because you could divide this by 20 and you can divide 20 million by 20. 20 divided by 20 is just 1, and 20 million divided by 20 is just 1 million. So now that you've done all this, you've actually put together a good ratio scale, a good clean ratio scale. Notice your final answer for a ratio scale, there's no units in there, and it's reduced as much as possible. Okay, so if you notice in this question, it was saying you got to find how long in kilometers would the train line be in real life if it were to go from this black X here, as it tells you in the problem, to this black X here. That's what the task is asking you to do. It does require that you calculate the ratio scale as part of your answer. That's what we just did here. In order to find the other part, how long in kilometers would the train line be in real life, you're going to take your ruler again and actually measure physically how far apart the black X's are. Try and line it up so that the 0 line on your ruler is right in the middle of that X, and then you would see how far this is. A good measurement would be 128 millimeters if you used a ruler on the paper that you got. If on the SITPROB or on a test, if you end up with something that's a millimeter off one way or the other, and I look at it and say, well, I can see how he would, depending on how he's holding the ruler, this is a reasonable interpretation, you're not going to lose marks for that. What I really want to be able to see is that you can handle the math behind it. And as much as handling a ruler properly is necessary, if you're off by half a millimeter, that's not the end of the world. So once you've decided that, let's say we're going to say this is 128 millimeters, this actual distance, you're saying I can set up a proportion now. 128 millimeters on the map is what I just measured. And I know that I can make this equal to the ratio I figured out here, 1 to 1 million. So let me represent that as a fraction. Okay? I'm going to write it as 1 over 1 million. The reason I'm doing that is because once you're comfortable with proportions, as so many of you are, the best way to deal with the problem is to set it up in a format where you know exactly what to do with it. Now here, this may look like I'm just randomly putting the numbers here, but this ratio scale, remember, the one on the left always represents the map, the one on the right always represents real life. The one on top here represents the map, the one on the bottom represents real life. So when I'm setting up this proportion to find the missing measure here, this 128, remember, that's what I measured on the map. That's why I'm putting it on the top of this fraction, not on the bottom. This empty space here that I want to fill in, that's where I'm going to come up with my answer for real life. So there's a bunch of ways you can do this. You can say, okay, if I multiply 1 times 128 to get this here, then let me multiply the bottom times 128 to find out what goes here, right? I could also put a variable in here, put an x, and cross multiply. I think for a lot of you guys, if your most comfortable method is using that mental shortcut, that's the fish method. You figure out, okay, if this is what I'm trying to find, let me start with the number that's close by, 128 millimeters, multiply across to get 128 million, then divide by 1, which gives me 128 million millimeters. All those answers are going to be the same no matter which of those methods you use, as long as you do it correctly. You should end up with 128 million millimeters as the real life distance between these two x's, the two ones on the map there. Now, of course, in real life, if somebody asked you how far it was from Montreal to Trois-Rivières, you wouldn't tell them it's 128 million millimeters because you wouldn't really know what to do with that. That's why in the question it says how long in kilometers would the train line be. So that's a more useful measurement, a more useful unit for what you'd want to know. So that means you got to take this and just do a quick unit conversion, figure out how many zeros do I got to get rid of to go from millimeters to kilometers. Just like over here we found you had to add on 6 zeros to go from kilometers to millimeters, you would take away 6 zeros to go from millimeters to kilometers. So that's pretty convenient for us because if you move the decimal place 6 spots to the left, you end up getting that there's 128 kilometers as your real life distance between Trois-Rivières and Montreal. And that's how you do not just this question, but any of these map scale questions.